Hello, welcome to my talk. I'm going to be talking about harnessing event-driven and multi-agent architectures for complex workflows in generative AI systems. It is a kind of mouthful of words, but as such, it is an exciting and also rather complicated subject matter. So I'm exploring that, and event-driven and multi-agent collaboration architectures should be the ideal for implementing generative AI systems. So let's go in and explore today. This is the quick agenda to let you know. I'll do a quick introduction and then I'll get into some background information of generative AI. And then we'll also introduce to the event-driven world and how would it be able to apply to the AI world. And then I'll discuss too about applying event approach to RAG, Retrieval Augmented Generation, and then also applying that to agents and workflows. Then some challenges of Gen AI, and then I'll share with you the resources. First of all, who is Mary? Who am I? I'm the AI practice lead at Calibrity, and I'm also a very passionate technical advocate. I was a technical evangelist too for the past 6 years, and recently, or 5 months ago, I became an AI practice lead, leading a small team doing AI work at Calibrity. I'm also a Java champion. I've worked primarily before this was like with more distributed systems. That's really the area of my passion. And then I've worked with reactive systems as well, very much like event-driven type of systems, also my passion. And about a year and a half ago, I was at DataStax and I got a chance to get into generative AI. And I feel that this is the place where event-driven systems, event-driven architectures can be applied, kind of generously to this field, but this field is relatively untapped. So I think it's very exciting. And so that's kind of what is about me. I'm also a very active community organizer. I'm president of Chicago Java Users Group, as well as the Chicago co-lead, chapter co-lead of the AI Camp. So now then just to start with a very brief intro and background of generative AI. We all know that AI all of a sudden became talk of the town since 2 years ago in 2022 in November when ChatGPT 3.5 came out. AI was already getting into our life too, but Gen AI has become the talk of the town. But first of all, let's kind of understand too, AI, it actually has been infused into all fabrics of our lives. But I like to also point out too, we can be the consumer, like here, like you're eating the cake, or we can also be the producer. We are the ones that actually will be developing, designing these AI applications, training models, all of these things. And so today's talk is mostly from the producer side, because we're here to build these systems. First of all, some very kind of basic understanding too. A lot of people have kind of got mixed up too with AI, with machine learning, with deep learning. So this is like the left side is a very basic model that kind of quickly explain AI is kind of the umbrella term that kind of essentially describes, we are going to mimic the intelligence of and behaviors too of human beings and other living entities. So it encompasses a very large kind of scope of field. But in order to be able to do that, we kind of drill down now. And there's essentially machine learning. And that's where we apply the techniques, right, of training the computer to learn. And this time too, we don't actively train it, so to speak. We're supplying it data in order for it to learn from the data and correct itself too. So essentially too, there are like a couple branches of sub branches of these techniques. One is supervised training, and then unsupervised training and reinforcement learning. But those though, learning from data just by itself isn't enough. So that's when we get into the core of this, kind of an onion, if we can describe so. That's the deep learning core. That's where all the neural networking activities are happening. And that's where a lot of research is being done. And then if you go over to the right side, that's kind of a little bit peeling deeper into this onion. As you can see, the NN stands for neural network. And then inside is where the LLM, the generative AI, where it sits. And then deep learning too is basically even deeper into this general neural network kind of space. And as you can see too, as such, generative AI makes heavy use of natural language processing. That's what I think it's kind of giving the wows to people because now it can understand human languages and generates, articles that are in human spoken form too. And then as you can see too, it's not possible without data. So data is a very integral part of AI and development. So let's take a quick look into this generative AI era. What is generative AI? It's a disruptive field, right? As we can see, in relationship to the other AI, machine learning, deep learning, this actually is disruptive field in AI itself. Because why? Because it has the potential to change the way we create and consume content, which it is already doing so. It generates new contents based on prompts. And these prompts, too, are not like what we are used to in the past with traditional AI, in which, traditional AI, even, or not just AI, I should say traditional computer program, in which we had to follow such a strict rule. What are you going to ask, your computer to do, your program? You have to give it like exact, parameters. If you kind of not even have the right type, it won't kind of understand, right? And most of the time, especially if you're a Java programmer like myself, you need to worry about the types and everything. Yeah, well, it's a great language, don't get me wrong, but it's just that it takes more time for us, right, as developers to be able to have to go in and kind of decipher what it means. However, for generative AI, is that you can just talk like the bot, as though it's another human being. So that's really kind of a big advance in here. And as such, too, generative AI tends to be on the creative side, right? It generates code, it writes an article and design new fashion, and you write a new song and all of these things. And so when it's compared with the pre-generative AI, that's predictive AI also can do some of these things, but then it actually deals more with like business, with weather forecasts, for example, business forecasts, something that has a time kind of line to it too. Whereas generative AI tends to be, if you write an article, it can be valid anytime, right, for an infinite period. So that's exciting. So if we kind of take a quick look too into generative models, right? So these are kind of the models that essentially think of them, they are your runtime for your AI. Just like, if you are a Java developers, there's virtual machine, that's your runtime that operates, or kind of decipher all the code and does its job. But the generative AI models is what is able to give the runtime for interpreting all of these prompts that comes in as well as also generate your responses. So these are kind of just all of the more popular models, right? And out of it is the GPT family of products from OpenAI, the 3.5, 4.0, and now 4.0. 4.0 mini, all of these two, O1, everything. And then there are also like other, kind of modes too. So let's kind of take a little quick look too. And there's also the generative AI apps too that are making use of these models. And as such, this is very a small little portion of what's happening. As we can see right now, things are happening real fast. There are plenty of apps out there and also more models too. And as such too, there with these models too, we're also trying to expand the modality. Think of, initially we're dealing with text and then you generate text, but now we can also see there can be image to text to image or video to image, all of these things, they're just multimodality within this fascinating field. And so stepping things up too, beyond the hype, right? LLMs, the large language models, has its limitations too. And there's no memory, and there's, giving probabilistic results, and the answers you cannot add attribution to it. And it's also very costly to kind of dealing with these LLMs. And that's why most of us do not train LLMs. We do not train the models because they are simply very expensive. Takes a lot of GPUs to produce them for the Gen AI type of models. And so in order to kind of make these LLMs more useful, that's why we want to explore into this event-driven approach, because we don't just live, with, kind of a one-shot type of kind of request to the LLMs, right? And it's fascinating. We can tell it to say, write an essay for us or compose a song and everything. And if you have specific tasks, it does its job very well. However, we live in a complicated world. We are kind of talking about, for example, even like book, let's say, right? Some example would be booking your airline tickets or make your flight reservation, essentially. And so it deals with many steps, and there's also a workflow, and the data is flowing through different subsystems or it gets sent over to another system. And it's actually, when you think about it, it's kind of perfect, right? It's a workflow. So it's perfect to kind of think of utilizing an event-driven approach to do that kind of work. Yet we're not there yet. And of course, too, with event-driven, there are plenty of benefits to it, too, which we'll get into in a second. So real quickly, to kind of finishing up this introductory part, there's a generative pre-trained transformer. As I kind of explained, it takes simple prompts as input and does all the pattern matching inside and then answers questions for the prompts. But as such, too, produce contents, but there's this whole set of data kind of flows through many parts of the system too, and primarily, through the model itself. So let's kind of take a little further. Natural language processing, I won't get into all the details, but it is an interdisciplinary subfield of linguistics of computer science that enables this generative AI to happen. And then large language models is really the type of machine learning or deep learning model. And as such, I already explained to it has its limitations. And as much as seems like, amazing, it incorporates so much data to it. We train it and there's, many dimensions of these things. But so let's kind of take a look at how these LLMs fit into this whole picture as well. And I think I already explained it a little bit earlier, but as you can see over here, LLMs fits into here, but there's also making use of all the data sciences stuff. But the thing is, the next part is to look into event-driven approach. So the event-driven world and AI, let's take a look. At the heart of AI, again, is the data. And then not only that, it's the flow of the data in many directions too. As such, we live, in a complex world and we work with data, day in, day out, we're dealing with data. So on the architecture level, we can leverage on an event-driven type of architecture to help, with generative AI, building generative AI systems. And also just a few things to kind of remind ourselves is that we're handling data too in different states. It can be at rest, right? Let's say if it's in storage at rest, and also like in transit too. It can be essentially too, it's being processed essentially too. And then also in use, right? And in transit, it's more like if you have to send data from one part to the other, right? That kind of stuff. And a lot of the communications that goes within it. And then there's also in use is when the data is being accessed or being updated, all of these things too. So these are kind of different states of data. And then the techniques we can apply to it is to use, like in the event world, is event streaming to help with communication, and then also the analytics too. For example, real-time analytics too, leveraging a lot too onto event streaming. And then event messaging as well. And this messaging part can be, utilizing techniques like publish, subscribe, right? PubSub type of broker kind of systems to kind of increase your throughput of messaging that goes back and forth. And then also event sourcing and CQRS as well. But these things, we won't get into all of the details, but just to kind of be aware of these kind of techniques that we can leverage on. Now, then getting into generative AI streaming usages, I was kind of thinking through too of the different areas that we can apply, kind of combining leveraging on event streaming type of approach to it. Now, on the generative AI apps kind of input is that we're talking about their prompts, right? The prompts that are coming from, it can be like from a command line system. You can be running some, kind of command line kind of interaction. And so inputs to the prompts from a user, a chat bot, for example, or a dialogue, then come in and type in all the requests. Or it can also be in a browser too. It can be from different devices, mobile apps, all of these things can come in, and also from program to program. And then there are also the intermediary steps. For example, like during a RAG kind of operations too. A RAG is essentially too, you are taking extra or additional input that kind of supplement what the large language models doesn't contain, right? Didn't get trained on. For example, some real-time systems too. You could be reading, some data from a Kafka topic, from any kind of pops up kind of broker that kind of picks up messages that triggers, based on a sync kind of communication. It can be picking up data from it or message queue. And then also can also be a raw kind of socket too. For example, I work for a company. Actually, I work for the Mercantile Exchange here in Chicago, and then there are also they're called people well, actually firms that are doing price maker. That's right, and they pump data in through sockets too. You can be picking things up from there, and then also file system or databases too. These are different sources. And then from there, you have to send the request over to LLMs. You need to do all the kind of assembling of these things. And then, of course, too, then after you receive output to the responses from LLMs, the responses will be sent from the LLMs. So all of these, as you can see, data is flowing, right? And we can look into all of this state. There's a lot of like in transit and then also in use, this kind of state we need to deal with too. Now, talking then about these benefits of the event-driven approach. So as we all know, and here too in this conference, I believe everybody is interested in event-driven systems. And the primary really benefits of event-driven approach is that, the dynamic nature of data and its flow patterns can be, easily be handled in an event-driven type of approach. And then also too, via event streams, you can actually allow the data to communicate with one another asynchronously. Because all of these components too within your event systems, they are all loosely coupled. They are not tightly coupled. So it enables like communications to happen kind of quickly. To me, I feel it's actually more mimic real life. Like who would ever go, let's say I'm go doing my Saturday shopping. I'm real busy. I'm trying to go to the deli and also order food, all of these things, and I could be ordering food and then in the meantime going to the shop and get stuff and comes back, and I get notified on my phone, my food is ready, kind of like that. So it helps too, with this asynchronous style of communication, making lives easier too, and you don't actually block any kind of I/O in that case. And then, of course, too, there's scalability. Flexibility is also greatly improved, right? You can independently scale your components without worrying about other parts of your system. And then also, too, integration of in a Gen AI scenario, we can actually be using different types of AI models that I showed you earlier. Some models are specifically good for certain things, so you might want to employ different types of models to do your work too. So you have different, kind of, well, now is a little ahead of time is talking about agents. You can have different agents working with different models. And then this with an event-driven approach, you can actually help with integrating all of them in communication as well, easier too. However, be aware of the following challenges with event-driven approach. They are more difficult to debug, right? All these components are independent and you're sending messages out. You have to make sure there are ways to track all of the messages. How do they flow from one point to the other? It's all usually more difficult too. And how do you track them, right? And all of the data that they carry when they change in state. And that's why too, I think with event sourcing and CQRS, perhaps in good way, a better kind of techniques to kind of track this kind of changes of state of data too. And of course, observability will need more work too for this type of approach. Now, let's take a quick look then into retrieval augmentation or retrievals, augmented generation, the RAG, right? Everybody hears about it for Gen AI. It's becoming kind of like, the talk of the town or something these days with Gen AI. What is RAG, right? Let's take a really quick look. It's a hybrid framework that integrates two components of the RAG models. One is the retrieval model. The other is the generative model. So the idea is to be able to produce text that is not only contextually accurate, but also information rich too. So that's the goal. And so there's the retrieval side, of this model, and all it does is like act like a librarian. It pulls in relevant information, again, from external sources, such as a database or a corpus of documents, a set of PDF files. That's kind of very common type of business applications these days. You are dealing with stack of invoices you need to go through for a finance department. So that's an example. And then data then is that, properly, of course, I'm being a little bit simplistic, but essentially you do need to go through maybe chunking them of these things. And anyway, so with that, you can then feed it over and then essentially too kind of you have to like generate your prompts and everything and then chunking and filtering all of these things and then have the data be ready and then feed it into the LLM and the LLM will then comes back with the response and then for the generative model to kind of write the output to kind of beautify your content too. So essentially too, if you kind of take a look at the generative model side, it's basically the creative writer, and it synthesizes the retrieve information and produce very coherent and contextually rich text too. So as you can see too, kind of quickly, kind of explain this model. Now again, this is just a model. It doesn't dictate how you do it. It's really up to vendors perhaps or how you can implement this model yourself, but essentially that's what it is. But as you can also see, there are lots of data that kind of flows between the two. Okay, so now then let's kind of take a look at the more exciting agents and workflows. So there are also now lots of talks too about agents, right? And because LLMs, again, has limitations, it can't do everything. We need some kind of way of handling complex workflow. So first of all, Gen AI agents, what are they, right? Within the software context, these are software entities. And what it does is it orchestrates complex workflows. And then it also help and coordinate the activities of multiple agents as well. And it's essentially to it process logic and evaluate answers. Those are some of its tasks. And of course, too, there are also agents that are actually their task is to do specific kind of things, right? And for example, you can be like mimicking like a software project. Inside a project, you have engineers working on development of the components, and then you have QA testers doing all the testing. You have the deployment expert to help you to deploy, and then so on and so forth, right? And project manager that actually will be the one that orchestrates, all of this flow. And of course, that's kind of a simplistic way of talking about it. Now, and there are also concepts of the multi-agent systems too. So now when we get to this part is essentially we're talking about these agents becoming autonomous. And so in an AI system kind of context is that you probably don't even need to worry so much about coding it up. And basically, you are letting the agent to figure things out on their own. They have essentially become more autonomous. But I also wanted to point out we are not there yet. The AI is not there at AGI or artificial general intelligence yet, but they can kind of still do certain types of work if they get trained to know what to do, right? So now we're then talking about multiple autonomous agents working together. This is a true kind of multi-agent systems. And each agent will specialize in it specializes in different tasks too, let's say, right? And then with agents becoming more and more intelligent itself, then you're also encouraging the agent to interact among themselves as well too. So essentially too, when we design kind of agentic system, we'll first have to kind of figure out the design and basically divide up some complex tasks into manageable subtasks. And then you can then leverage the strengths of different AI models. Maybe certain agent is doing some work and you want to assign, I'm a development agent. Maybe I'm going to use a Copilot, the Codex model to do some of this development work. And then I have another model that does better work with writing. Let's say Claude model is really good, right? The Anthropic Claude model. And that can be more like a project managers to do that kind of work. So you can associate like different agents with different models as well in that case. And then the idea is that you have these multi-agent systems. They all are built kind of efficiently on their own, but yet they can all kind of communicate with one another. So we are kind of talking about increase the robustness and fault tolerance of these systems. So now let's take a little further to look into combining the event-driven architecture and multi-agent for Gen AI systems. So we can kind of think of, right, in EDA systems, a lot of, these are all, we're talking about events, and it's basically, we can leverage on events to essentially coordinate the agent activities, and then also leverage on event streams that helps with asynchronous agent communications too. And then, of course, the workflow themselves is event-driven workflow that can orchestrate. You can use that agent to orchestrate the multi-step kind of generation too. Now, on the other hand, for more key components too, if you kind of take a look at, we can kind of think of using an event bus to manage event streams, and then API gateway to handle external events. And then the agents themselves are really autonomous components with specific capabilities, each of them too. And then again, with each one of them, they can be working with certain AI models too that are underlying the generative models side of things too. So for example, GPT, you can have, some models is working with GPT. And as I mentioned, you can be using Anthropic Claude, which seems to be really good with writing. And that's one I think. Dolly is with generating images. So maybe you have a graphic artist kind of work, you can be using Dolly underneath the hood, that type of stuff. Okay, and then let's take a look too quickly, right, about event types and agent types too. So you can be like types can be like a user request that can initial generation requests and then subtask assigned. An agent can be given a special type subtask. And there's also result generated that can be output from an agent and model. And then there are also final response completed result for the user too. And then on the agent types too, on that side, you can have coordinator that decomposes tasks and assigns to different agents, and also like generator that will produce content using AI models. And there's also evaluator that helps with assessing the quality and relevance of the generated content, and then also a refiner to improve and iterate, right, on initial outputs as well. So as you can see, agents can be assigned different specific tasks to do its job best too. Oh, okay. So now it's actually wanting to share with you a paper from archive.org. And I've shared this link here. It's basically from AutoGen. Microsoft has an open source AutoGen is their multi-agent library that enable next generation LLM apps, via multi-agent conversations. And I found it to be quite interesting. And you can also like have humans in the loop as well. So as you can see, without going into all the details, it is actually quite complex. You can have, AutoGen is pretty good with conversation too. So you can have different conversations, sayable agent, and then also agent customization and dealing also with cases of multi-agent conversations, flexible conversation patterns as well. And then as you can see, there are example of agent chat in which you can also plug in humans too into the loop as well. So again, this is just a really quick kind of example for you to look at to kind of combine. And as you can see, there are lots of communication in between. So you can definitely be using event type of messaging too to kind of go between, the communication part as well. Okay, so here too, let me really, really quickly go take a look too at this agentic design patterns. I find it very interesting from Dr. Andrew Ng, and so he described these four design patterns. One is reflection, and then tool use, planning, and multi-agent collaboration. So I wanted to quickly go through. Reflection is essentially, if you kind of look at it, you have agents that is capable of doing reflection. So normally too, you would prompt the agent to do something for you, but then you also have another agent over there. It's basically critic, right? Act as a critic, was be telling the coder agent to say, in this case, right, I have some error in here. Can you redo it? So in a way, it's reflective. You want the coder agent in this case to keep refining, to giving you better and better results. So this kind of agent can essentially be autonomous too to help you with refining your answers. And then there's also the tool use agent too. So what it does is that you want to also kind of giving the agent information that in case they don't have answer, then go and search for answers in the web or kind of do some work. And basically you're giving this agent some hint to kind of fall back on if it doesn't find the answers that you're looking for. So that's tool use. And this one, to wanting to point out, is from Crew AI, is a quite a popular multi-agentic library now, is becoming more important. They also have essentially agents too, and a role play kind of system. And essentially too, these agents will help each other out too. If one agent doesn't know, it actually knows to look for another agent and ask for help too. So that's a kind of very interesting thing. And as a result, then it goes through the process and then assign task, and then have the outcome as expected too. All right. And then there's also planning. Planning is a little bit kind of tricky. It's still kind of new. You could be like, asking the agent to do some work, but without telling it all the steps. So then you kind of basically let the agent figure out all of the steps itself. Now, for this too, particular pattern is a little bit newer. It apparently is not very accurate yet, but then essentially you want the agent to really take on more initiative to plan things out and do all the steps itself too, is the idea. So I won't kind of get into all the details, but there's also this multi-agentic collaboration. And essentially this one is, as you can see, I'm taking, this example from this particular chat dev, kind of like a game to mimicking like a coding, an IT shop doing coding project for a consulting firm. So as you can see, each agent is doing different things, and then you have overseeing agents to help with kind of making sure that the final product is being produced too. And apparently this is actually, the code is there too, and I've shared with you the code or this paper. You can take a look and play and get a good idea of it too. Okay, so I think I'm kind of running out of time, but these are like the few multi-agentic libraries: AutoGen, CrewAI, and LangGraph, and there are more too, but these are essentially Python libraries. Challenges, right? Let's get to it. So make sure that, when you're working with this, these are very complex system design and coordination. You have to ensure consistency across distributed agents, and also have to make sure you handle the failures and partial results correctly too. And make sure you also optimize for latency and resource usages. Now, also keep in mind, there's still hallucinations in Gen AI with the LLMs, ethical concerns, and sustainability issues with these expensive Gen AI usages too. Okay, so here is the resources, and this is, first of all, is my slide deck in here if you want to get a hold of it. And then also the information about the paper, the archive paper, and also the different agentic libraries that I've talked about in here. And then I also have a podcast called the Elusive AI Podcast, and also my stream too on my Twitch and also my YouTube channel. So I encourage you to follow me, and I'll be demoing some of these things too in coming days. With that, I want to thank you so much, and I really appreciate you listening to this talk. I hope you reach out to me, and I like to have more conversations with you. Thank you.